Hi, welcome back to another edition of View from the Road. I'm Bob Abramson. In this series, I am talking to my colleagues at Walltron who are on the road week in, week out, talking to our customers, and we have the opportunity for them to share what they're hearing in the marketplace. And today I'm here with Joe Schultheis, who is our Director of North American Sales. How are you doing today, Joe?
Good morning. How are you?
I'm doing well. Why don't you take a couple minutes just to tell everybody who you are, what you do at Walltron, how long you've been with us, some of the basics so they get an idea of who Joe is.
Sure, no problem. Yeah, my name is Joe Schultheis, Director of North American Sales for Waltron. I've been with the company for a little over 23 years. The first 10 years of my tenure at Waltron was on the manufacturing side as in the production area, production supervisor, manager. So I had a good feeling for how the products were built, how they were tested, QA, QC. And then in 2009, when the economy tanked, I moved over to a part-time sales role, which turned into a full-time sales role in 2012. So I've spent the last 15 plus years doing some sort of sales support, whether it be part-time or full-time sales. I moved into the Director of North American Sales in 2014 when we came under new ownership. And you just spent the last 10 to 12 years building up our rep network, working in conjunction with great channel partners, along with also doing direct sales for areas that we just don't have coverage or just don't require coverage.
Yeah, okay, wow. So it's fair to say, with your history with the company, you don't just know what our product line does, you actually know how they do it because you've been inside the guts building this equipment.
Yeah,
So
correct.
So that gives
Yeah.
you some pretty good insights, I'm sure, as to explain why our solutions may really help clients out there. Is that fair to say?
Yeah, I think so because part of what we do is being able to understand how our competitors' equipment works and operates and trying to identify how we can improve our products. We're continually innovating and updating our product line, not just for sodium or silica or dissolved oxygen, but we're always looking for new ways to improve the product. And the main goal being trying to have a product that's reliable, sustainable, and just require the least amount of maintenance. The less we can get a customer touching equipment and just having it run, the better off the customer will be, and obviously the plant will be. The goal is to be as hands off as possible. Of course, some products do need some attention, but we do try to minimize the amount of interaction between the end user and our analyzer line.
Makes sense. Lofty goals, and I think that we're doing a fairly good job on delivering on those promises. So you just got back from being on the road. What have you been hearing? What seems to be top of mind for some of our clients in any industries that we're serving?
Well, a lot of customers are getting out of their spring outage, so they're getting ready for the summer run. I think, as anybody can see, the temperatures are rising, and that means air conditioners are running, which means power demand is there. And a big part of what we do is try to go in and identify needs and pain points that customers are realizing or identifying after they come out of an outage. And it's what we're seeing is a lot of equipment is getting aged. And most of these facilities that we're visiting are 15 or 20 years old now. The lifespan on a lot of this technology is right around 10 years. So if you're getting anything beyond 10 years, you consider yourself pretty lucky. It's not uncommon to get 10 or 15 years, but just the way technology changes, most customers are looking for the latest and greatest. And if your company's doing it right and correct, you're improving products, and what you had 10 years ago is not what you have today. You just think of a cell phone, how it went from a flip phone to a cell phone will pretty much do anything for you now. And I think that's a great analogy. The evolution of and our analytical equipment falls in the same pattern.
So let me ask you this. You mentioned temperatures, it's getting hotter, so we're going into the peak summer season. And forgive me for the way I may put some of this because I'm a layman, somewhat new to this industry. But whatever you may or may not think of global warming and what may be causing it, temperatures over the last few summers have gotten hotter. It's just, you can look at the data, the temperatures are rising. The summer season, I think, puts more stress on power plants than the peak winter months. And if we're having hotter summers, I would imagine that's putting greater stress not only on, say, power plants, but also on our analyzers or anybody's analyzers. So, uh, is that true or not true? And if so, so is this 10-year lifespan of an analyzer, is that being stressed? Is it pushed? Is it actually, you know what? In today's environment, you should be looking at 8 years or 7 years, and what are we doing if if it's an issue to counter that, to make sure that, hey, we can still have longevity, reliability, durability, which is one of the benefits you mentioned. That makes sense.
Yeah, I think that the big part of it is just being proactive and making sure that you're educating the customer as to what they've purchased and what their minimum requirement is for analytical equipment. If you're talking about a colorimetric analyzer, there's going to be reagent changes and there's going to be tubing changes. When you're talking about sodium analyzers, you're talking about chemical changes, reagent changes, probe maintenance, probe replacement, retubing of analyzers. These are just minimum requirements. And so often we see facilities that are really either stretching these products beyond what their normal capabilities are, or just not privy to the fact that, hey, we need to change a sodium probe every year and a half or every 2 years, or we need to regenerate a sodium probe, every quarter when we're doing a calibration. That's a big part of it too, is just trying to make sure that the customers are aware of what the expectation of the equipment is. And if they do run into an issue or a challenge, to be able to start identifying, have you done this? I almost have a maintenance checklist and go through and try to identify where the problem might be really before it gets too far out of hand. So that's a real big thing for us.
So this maintenance issue, this maintenance checklist, is you and the folks that are reporting up to you, how much is that impacting your time to making sure to help these people either pay attention to this, or if their current clients, maybe do a little troubleshooting before they panic? Because I was speaking with Howard, and he was relatively new to the team, but he mentioned that staffing is an issue. So it seems like we might be in a perfect storm type of situation where there's more stress being put on the systems, but less people at these facilities to manage that stress. Are you seeing that, and how are you helping them out, and how's that impacting us and in the industry in general?
Yeah, I think, what I've seen over 20 plus years that I've been with Waltron is you're exactly correct. There's been a changing of the guard. You've got a lot of these baby boomers who were lifelong plant employees that have retired, and they're just taking years of experience and knowledge with them. And in many cases, they're not really passing down, or they're not given the opportunity to pass that knowledge down. I've seen so many times a chemist may retire, and then next thing you know, the job's posted, as opposed to maybe having somebody come in and be an apprentice and work under that individual, because there's a lot of moving parts in a power plant or a paper mill, and the water chemistry is such a small portion of how the process works, but it's one of the most vital parts of the success of generation and generating electricity. If you have bad water quality, it will cause a problem and can take plants offline. And you get somebody that might just be out of college or only have a couple of years of experience. I've started to see people being promoted from an instrument and controls technician to a chemistry role where it's completely different, trying to make sure that you're educating people, like I said, not even so much on our equipment, but just understanding the importance of why you have the equipment there, what it's being used for. I find myself saying a lot of times, whether you buy a Waltron or someone else's, this is a minimum requirement that is required of you in order for this equipment to work correctly. So, like I said, at the end of the day, I like to consider myself more of a problem solver. Yeah, we're in the business of selling analyzers and supporting customers and stuff, but being able to identify problems and finding solutions, even if it's sometimes not a Waltron solution, I feel that's part of our responsibility to the customer and the end user, is helping them find a solution to whatever their pain point is that particular day, that week, that month, that year, whatever it might be.
So interesting. Sounds like some of the positions or people who are interacting with our equipment historically had a chemistry background, and maybe that's not so much the case anymore.
That that's
Non-chemists doing what was typically a chemist's job. So that's pretty interesting. Is that fair or not fair? Or
Yeah, I think it is. And like you alluded to it earlier, you look at the coal-fired power plant that might have been running in the 80s or 90s, and they may have had a couple of hundred individuals working there. Now, all of a sudden, say that plant is decommissioned two out of their four generating units, and now their staff went from 200 to 50. The work is still there. It's just they don't have the personnel and the knowledge to be able to maintain that. Plus, the fact that you're seeing a lot of these base loaded facilities that are now becoming either cycling plants or peaking plants. That those plants and that equipment was not designed to continually go up and down. It was designed to run for long periods of time, come off, make repairs, start the car back up and get it to full load and just let it run. And if there was a problem, then they would pull it off. But so much now it's up and down and it's just so hard on the equipment. And the analyzers fall into the same thing. If you're not maintaining the equipment and making sure that stuff is in tip-top shape, it's not going to be a benefit to the customer or the plant. I've got some people that have been telling me, hey, we don't even use these analyzers anymore because we only run for 2 days. And by the time we get up to where we need to be, where the equipment could start providing good, valid information, it's time for us to come offline. So we don't even use it. And it's baffling to hear that, but I also understand the flip side of it too, that there's a thousand other things they're working on. Calibrating a silica or sodium analyzer is the last thing on their mind because it's only going to provide useful results for a 24 to 48-hour window in some cases.
well, that's interesting. We have this increased cycling off and on, which was not really what these plants were built for. And I guess in some cases must be, I don't know, you said it's only they're up for a day or two. I imagine it's a backup facility that would be in that position if they're only running for a couple of days. I want these conversations to be practical to the people viewing this. You and the team and just Walter in general, we've been at this for 100 years. There's a ton of expertise. And when you're talking to clients that regardless of the analyzer, you're trying to give them some practical tips to help them troubleshoot or just make decision making or just make sure things are up and running. So maybe if we can, if it's fair, let's drill down a little for like a use case. So if it's, I think you mentioned one of the key analyzing parameters we're testing for is sodium. Specifically, what's on the sodium checklist? Because not all analyzers have the same components, do the same things, operate the same way. So let's just drill down to sodium. What are the tips, the Waltron expertise that we could say, listen, regardless of your sodium analyzer, this is what you need to be doing to making sure it's up and running, the things are checked, that you get the maximum value out of this, and when you're protecting your plant at the same time. Is that fair? Can you address that?
Yeah, I think with any sodium analyzer, the most important point is to make sure that the analyzer has been calibrated. So many times we'll go into a plant and you'll see a number that in the plant size is a great reading and it's what they would expect it or think it would be. But in some cases, it's just I can tell right away when I look at a sodium analyzer and it's reading zero point zero 0.02 ppb. I know that's not correct unless maybe you're at a nuclear facility, but your standard run-of-the-mill combined cycle gas-fired power plant is not going to have those types of readings. Their water quality and the way the plants are set up are just not geared toward that. Calibrating is one of the most important factors of it. Even too, if you've been offline for long periods of time and maybe the analyzer calibrated right before you went into an outage, but just making sure that has taken place. Also making sure that the probes have either been stored correctly or are not 5 to 6 years old. So many times probes that are sitting have been in there for so long that will cause a problem. And then obviously your chemicals too. Every sodium analyzer has some sort of reagent buffer, whether like for Waltron, we use ammonium hydroxide as our standard buffer. A lot of our competitors use diisopropylamine or DIPA, making sure that your buffer is been replaced. It's designed to raise the pH level in the system. You want to make sure that. And then obviously you have good calibration standards. That's a big part of it as well. The one nice thing about the Waltron analyzers is we do manufacture our own calibration solutions in a 100 ppb and a 1 ppm. They're very stable solutions, unless of course people are putting their fingers in them, but they very rarely will they get contaminated. So they can sit there for longer periods of time and be able to hold their values. But that's the big points there is making sure that addressed all those issues. Obviously, proper flow to the analyzer is another concern. You've got to make sure that you've got enough flow so that the probes will recognize the solution and be able to provide useful results when the unit is calibrated.
Excellent. So let me, if I can, drill down even more for the non-chemists that may be looking at this. Say, oh, I didn't know. Are there some red flags? So, like you mentioned, you get a reading for calibration of 0.25 ppb, and you say there's no way your sodium. That's not right. What should people? What's the minimum they should be seeing there, or what's the range that someone should be looking at to say if you're below this, you have an issue?
Yeah, I guess I'm not saying that it couldn't happen, but if somebody is going to be like around zero point 0.1 ppb or lower, I would start to question the analyzer accuracy at that point, unless they've been able to check all the rest of those points off. It's just the majority of customers are wanting to see less than 5 ppb, less than 3 ppb, less than 10, less than 20. Those are pretty common parameters for the various sodium samples that customers will be seeing. So when you see an outlier like that, where it's just either at the bottom of what the resolution of the analyzer would be. It just, I don't know. It's like a red alert for me. There's certain things you're looking for. Same thing like on a dissolved oxygen. You see it reading zero point 0, it's that's not correct. It's just there's certain things that you just see constantly that you just know there is no way that analyzer is functioning correctly. And then a lot of times you're meeting somebody for the first time, you're able to almost set the script of what's going to happen. Hey, we're going to go walk in your lab and would not be surprised if we see this and this, but I would also say that I don't know that's necessarily correct. And what it does do is it does help build a little bit of credibility and trust, right? If the customer is meeting you for the first time, it's important to get a good report and be able to show the end user that you know what you're talking about. We're just not, like I said, we're just not winging it. We're looking for solutions. We're looking for ways to help the people even if it's not our equipment. So if we can point something out and say, hey, you might want to check that, you might want to have that calibrated, I feel like I've done my job and my due diligence to the end user for the time that they've given me to allow me to come in and talk about Waltron for them.
Okay, cool. Excellent. Good information. So probes, you said, hey, people are running probes that are 4 to 6 years old. So again, for what should people say? Like, when should they be replacing their probe? Is it 3 years? Is it 2 years? I know not all are created equal. When do people really need to get serious about replacing their probe? What would be your recommendation? Every 3 years? What is it?
Yeah, we've put a big emphasis this year, especially within Waltron, is going out to our sodium users. All of our probes are date coded, so when a probe leaves our facility, it'll be date coded with the week and the year that it was shipped. It's done for two reasons. It's done in case a customer has a warranty issue, then we can say, hey, listen, this falls within the warranty period. Here's your warranty probe. But for anything else, it's basically just to see where we're at with that. And we've been telling customers if you're upwards of 2 years, it's probably time to start looking at replacing the probes. Just because the analyzer will pass calibration in some cases, but it may just not give the responsiveness that it needs. And sodium is something, these probes, because they're calibrating with a 100 ppb and 1,000 ppb, they're designed to be able to detect sodium levels at very low concentration. You just don't want to lose that reliability on those probes. So that's why I said anything that's date coded in 2023 or earlier, we've been telling the customer, hey, you might want to budget for this. You might want to get a new set of probes. It's about time. And in most cases, I think customers will also be able to look back and say, hey, we've had this analyzer in place for 5 years and we really haven't had to spend a lot of money on it. Yeah, let's get a new set of probes. If you're buying probes on a regular basis, there's probably an underlying problem that's going on. I know some of our competitors require regeneration of probes on a monthly basis. And though that's a good practice, it also does cut into the life of the probe. So we recommend the same type of service, but not on a monthly basis, just to be able to extend the life of the probes so the customer can we like to see them get at least 2 years out of it. But it's not uncommon for people to get beyond that. But like I said, at that point in time, you are flirting with the
Right.
potential of having a problem.
And you said storing. What are the do's and don'ts of storing a probe? What are you seeing out there that people like, for God's sakes, please don't do this? What is that? What's the story?
You always try to tell customers, don't let the probes go dry. I get it. You're coming into an outage or you're coming offline. If you're going to be offline for a couple days, I'd say it's probably not the end of the world. But if you're going to be in a month-long outage or 6-week outage, those probes are need to stay wet. And basically, when we ship the probes, they come with two little containers that protect the tips. And for our measuring probe, we tell the customer to grab like 1,000 ppb, the 1 ppm solution, put that in there. And then for the reference probe, just take some of the 3.5 molar KCl and just put that in there. But you want to keep those probes wet. And you also want to keep them in solutions that have sodium in it. I've had some customers that will put their systems on DI water because they want to keep their pH probes and their conductivity probes. And that's fine if you want to run DI water on the sodium probes. But if you're going to do that, you need to make sure that you're calibrating the analyzer. Most folks will forget that point that, oh, we've got it on DI water, there's no sodium in there, the probes are staying wet. But what happens is they will get acclimated to that basically 0 ppb of sodium water. So then when you do put it online, there again, they may be dormant. They might not be able to see the sodium solutions. I always tell people, if you're going to be offline, store them correctly. If you've got water going to your sample panel and you want to keep all your probes wet, because we do offer auto calibration, I would recommend the customer setting it on like a every 2 week auto cal and just let those probes get blasted with the low and the high solution, knowing that the calibration values aren't going to mean anything to the plant. And it's going to obviously consume a little bit of your calibration solutions, but it's a lot less expensive to replace a 1 gallon bladder of calibration solution than it is to replace a set of probes because you thought you were doing something correctly and in reality you were harming the probes, so to speak.
Got it. All right, one other thing I've jotted down here. So you mentioned different chemical reagents, DEPA, and then ammonia. I'm not quite sure I caught that.
Ammonium hydroxide, yeah.
Ammonium peroxide. So again, what's the, I guess they have a shelf life. Is that the problem? They get stale. What's the issue there and what should people be looking for?
Like I said, we use ammonium hydroxide, and the way our system works is it pulls the vapors from the solution. So we have a 1 liter bottle that gets filled basically to the top. And then after 30 days, when you go back, because we do recommend that the customer replace it monthly, there'll be about anywhere from say 3 to 500 milliliters of solution. Well, that residual is water. So the analyzer basically will pull the vapors from it. And then what we recommend for customers is to dump that solution 100% and refill it back up. And that's how the buffer stays fresh. In the case of diisopropylamine, it consumes itself. We do offer diisopropylamine. It's more prevalent in our European customers. I do have a couple of folks in the US that use it, but I would say probably 95% or better of our customers use ammonium hydroxide. And it's becoming more of an environmental concern as well that the diisopropylamine is a highly toxic, highly flammable reagent. A lot of these facilities have EPA regulations or they have discharge requirements that don't allow for these things to go down the drain. And that's a big thing that we're really seeing almost in the pulp and paper industry, where a lot of these facilities have the same brand analyzer that uses this solution, and their environmental and health and safety coordinators are saying, hey, we can't use this anymore. We need to come up with a solution. And that right there becomes a target point for us that, hey, we do have a chemical that is a mild corrosive. You're not going to get around that, but it uses the vapors from it. There's not going to be any real solution. It's mixing with the customer sample, so it is diluting it down. So it's in such a small in quantity that it really is not toxic and it can be released down into the drain with no issues. So
Right.
that's really the big thing for us. And like I said, especially in the pulp and paper industry, that's been a real big target for us is being able to identify those customers using those types of analyzers and bringing in a solution that's going to be beneficial for the end user.
Oh, great. Hey, you've provided some pretty practical tips for folks out there. I think that this will be much appreciated. Any closing comments or anything else you want to share that you've been hearing out there on the road before we ring off? Because I know you're busy and got to get back out there.
Yeah, like I said, everyone's coming out of outage season, so I think the important thing is to try to gather the list of analyzers or products that you're looking to do because before you know it, it'll be fall outage time. So now this is the time to get your laundry list together, have us come in, take a look at everything, get an idea. A big part of what we like to do is come in, take a look at the sample panels, try to see what product's going to be the best option for the end user. And in many cases, like our dissolved oxygen line, we've got 3 or 4 different packages that we can offer depending on the customer's budget or what their sampling points are and needs. The same thing with sodium analyzers. We've got a couple of different options, just seeing what's going to be the best fit space wise, how many samples they're trying to run, but just really try to get an idea of what you'd be looking for in the fall and then take the time to coordinate a visit and let's sit down and talk about what you have coming up and how we can help.
Great. So thanks so much for your time. I really appreciate it. I think our viewers are going to really like this. So again, really thank you, Joe. Have a
Uh,
great rest of the week.
all right, you too. Thank you so much. Take care.
Thank you.
All right, bye.